Hi everyone, and welcome to this my video on independent events. Yes, my name is Darren from Maths Guru. Yes, Maths Guru, my little corner of the interweb, where I upload videos of maths content, hoping to help you smash maths. Hopefully delivering it in an easy to understand way. Well, that's at least a lot of the feedback on my YouTube channel actually says as well. Now behind me you will see our learning objectives, and everything I'm about to write on it you can download once again from Maths Guru. There are videos on there, downloadable lesson notes, VCAA exam questions, and so much more. Now if you're not watching this in Australia, don't worry about it. It's fine because maths is universal. So the learning objectives today are understand what it means for events to be independent, understand how to show that two events are independent using probabilities. Okay, now again, this is building on a load of videos previously that again, downloadable or viewable from mathsguru.com that deal with probability for the mathematical methods units 1 and 2 course here in Australia. Okay, so if you haven't watched those videos, please go back because it's sort of building up, particularly on the video I've just recorded about conditional probabilities. Now, what on earth does it mean to be an independent event? Well, let's look again at the formula that we had from our previous video that said the probability of A given that B is the probability of A and B divided by the probability of B. Now, again, if that doesn't make any sense, there is a video for you. What happens if we look at the probability of getting ahead given that a head has already happened when tossing two coins? So we're looking for the probability of a head given that a head has already happened is going to be the probability of a head and a head divided by the probability of just getting that second head. Right, well again, if we were to draw a tree diagram, we would know that the probability of a head and a head is effectively going to be a half times a half divided by the probability of a head, which is a half. And so lo and behold, we are given but a half. So what we're actually saying is that the probability of a second head, given one has already happened, is exactly the same as probability of getting a head, all right? And that actually is the definition of independence. If we can show that two events, if we can show that when two events, the occurrence of one event has no effect on the probability of another occurring, then we can say that the two events are independent. Now, again, another mathematical definition for your summary books if you're allowed to use it. That would suggest the probability of A, given that B has already happened, is actually still the probability of A. It does not matter that B has already happened. A retains the probability. There's no effect or no change. Now, obviously, if we take our original formula here and use this to substitute, then what are we going to get? Well, we're going to get the probability of A given that B is equal to the probability of A and B divided by the probability of B. But I now know that for independent events, that can now be rewritten as the probability of A. Again, all I've done is basically substituted. When I do a bit of rearrangement, multiply those together, then what I'm going to get is the probability of A and B is going to be given by the probability of A times by the probability of B if the events are independent. So if we can do some mathematical calculations that finds the probability of two events ANDed, and that is exactly the same as the probability of those individual events multiplied together, then we can say they are independent. And that's pretty much the whole point of this video. Now, this is extra stuff, and thank you so much, Cambridge, for allowing me to use your examples. You guys rock. Really, really grateful. For events A and B with PRA not equal to 0 and the probability B not equal to 0, the following three conditions are all equivalent. So again, the probability of A, given that B, would be equal to the probability of A. It doesn't matter that B's already happened. They are independent. Likewise, we can swap those over. It would suggest, therefore, the probability of B, given that A's already happened, is the probability of B. And we've got that one there that we've just proven in the previous slide. Now, obviously, it says here, in the special case that the probability of A is 0 or the probability of B is 0, then basically that condition still holds, because what you're going to end up with, in which case, is you're going to get 0 on that side. One of those is going to be 0, and as 0 equals 0, they are basically independent. Don't you just love maths?